Hello and welcome back to our YouTube channel. Please subscribe to support us. And in this series we are constructing this almost ready to fly radio control flying model of a Douglas DC-3 from VQ Models. Now before we get started this time, there is an issue we need to address, and that's born about from choosing a 4-cell battery pack predominantly. We're going to do an approximate centre of gravity check.
So with the flight battery installed and the centre of gravity from the instructions marked on the root rib, you can see that she's very nose heavy. So to achieve an acceptable centre of gravity for flight, we're going to need to move the battery pack aft quite a long way. And the only problem here is that this is where the servos are meant to fit. So we're going to have to move them somewhere else and extend the battery tray aft.
So in this episode we shall fix that and finish that pesky centre section wiring.
So we will start by shortening these pushrod outers, and the elevator and rudder servos will live in this bay. If anything, access is better in this bay once the wings are removed. So I set about to draw this fancy servo tray to cut on our laser. But in the end, I just couldn't squirm it into position inside the fuselage. It just wouldn't fit. And so I ended up cutting it into 2 bits on the bandsaw. So with my hands being in the way to fit this tray, there wasn't much to see on camera. So let's just take a look at the results. So this is the tray that I mainly cut away, and you can see I rejoined it with this piece of wood. Then we have the elevator and rudder servos, and the elevator pushrods are joined with this aluminium block with a 3rd wire going to the servo. It's very important that you file flats on the end of the wire so that they don't slip. And then a similar block arrangement will actuate the tailwheel steering and the rudder. So let's make the battery tray extension from this piece of light ply. And first we're drilling some holes using a hole saw mounted in the pillar drill. Then using the bandsaw we'll cut it down to size before putting on a dust mask and sanding the edges nice and clean using the belt sander. Now we will join the holes using the motorised fret saw, and the idea of this large hole is to pass the EC5 connector through for the battery. After filing the edges, we can fit it to the aeroplane using CA glue. You might just be able to spot the triangular balsa fillets that are added to the top of the servo tray that we made earlier. Now I'm adding these beams for a Velcro strap to hold the battery down securely. And now back to the tail section. The clevises will get a keeper made from a small piece of fuel tubing before the lock nuts are tightened up. A bit of care is required whilst fitting these vacuum moulded covers. Here I'm using a step drill to avoid splitting the part. Once again, I'm fitting the clevis with a fuel tube keeper and then tightening up the lock nut. This cover will be fitted later and will house a white LED.
So now back to the centre section, and we're going to tackle this wiring together. A little bit of time and patience in the workshop now will pay dividends out at the flying field. Let's get started.
So hopefully this schematic will simplify things a little. First we have to connect the 3 colour servo cables to the receiver, the elevator and of course the rudder tailwheel steering servo are right there, so that's quite easy. However, the ailerons are out in the outer wing panels, whilst the flap servos are in the inner and outer wing panels. Then we have the servoless landing gear cables and the throttle cables to the electronic speed controllers. Next we've got the power cables, so the big red and blacks, and they run from the electronic speed controllers to the flight battery and also to the battery eliminating circuit BEC to run the receiver. Then we're having lights, so the battery at 14.8 volts is going to run these 2 series lighting circuits of LEDs connected to the battery balance lead. This is how we calculate the size of the resistors required. So the first circuit then, we've got the forward voltages of the LEDs added up gives 12 volts. The battery is 14.8 volts minus 12 gives 2.8 volts, which at 25 milliamps, Ohm's law gives us 112 ohms. Now I haven't got any 112 ohm resistors, but I do have 2 220 ohm resistors which wired in parallel will give us 110 ohms, close enough. The next circuit's a little easier. The 2 forward voltages added together is 6.3 volts. 14.8 minus 6.3 gives 8.5 volts to drop at 25 milliamps, gives us a 340 ohm resistor. So here is the 25 pin wing connector secured to the upper surface. Could you imagine each time you put the wings on having to connect all 12 connectors through to the fuselage? And this makes that a one-step operation. And this is the mating counterpart that fits in the fuselage. The wing tip panels connect using these 6-pin multiplex connectors. In order for this to work, I've had to group together the servo red and black power connectors, the other connections being the 2 signal wires for the ailerons and flaps, and the 2 pins for the lights circuit.
Now of course none of this wiring, or indeed any of these plug and socket components, are included in the kit, and VQ models fail to mention anything about the wiring. I guess you could use servo extension wires to connect all the various servos up, but it would be a pain. I do hope that our hard work pays off in the end. Please, as ever, subscribe to support our channel, and we'll see you next time.